Smart culture, science.
Let's have a look at this question. A crane on a building site lifts a pallet of bricks of mass 3.5 times 10 to the power of 3 kgs from the ground to a height of 22 meters. A. Calculate the work done against gravity. B. The input energy to the crane motor is 2.5 megajoules. Calculate the efficiency of the system. So let's start with question A. All right, so here we have to calculate the work done against gravity. We have to calculate the work done against gravity. All right, so what we are going to do is we are going to start by writing down the formula. Okay, so work done against gravity is calculated by multiplying the mass, gravitational acceleration constant, and the height. So what is the mass in this case? Now we will substitute the values with their units. What is the mass in this case? It's 3.5 times 10 to the exponent 3 kilograms, right? All right. And what about gravity? That's going to be 9.8 Newton per kilogram. Okay, and the height is 22 meters, right? 22 meters. So if we multiply all of this together, what do we get? We get 754,600 joules. All right, but this is not our final answer. Now we have to state it neatly and we have to convert it to megajoules. So we are converting it to megajoules first. So we can say that the work done is equal to 0.755 megajoules. Or it can be 7.55 times 10 to the power of 5 joules if you want to write your answer in joules. Okay, let's move on to B. So here we have to calculate the efficiency of the system. We have to calculate the efficiency of the system. They tell us that the input energy to the crane motor is 2.5 megajoules. All right, so efficiency compares useful output to input, right? So the useful output here is basically the work done against gravity. We ignore losses other than those already accounted for in efficiency. So what we are going to do now is we are going to use this formula. Efficiency is equal to the useful output energy divided by the useful input energy times 100. This is the formula that we are going to use. Okay, so now we convert the input energy to joules. I'm going to use this number over here, so I'm going to use the exact number. So then it will be 754,600 divided by the total input energy. So that's this number over here. So that's going to be 2,500,000 joules. And then we have to, of course, multiply this by 100. And if you punch this into your calculator, you will get 30,184%. And if you round it, it will just be 30%. The efficiency of a diesel motor is 35%. Calculate how much useful work is done by the motor for each megajoule of input energy. Okay, so the efficiency is equal to 35%. The input energy per case, in this case, is equal to 1 megajoule. 1 megajoule. Okay, so what we are going to do first is we are going to write the relationship. So useful output energy is equal to the efficiency as a decimal times the input energy. I'm going to read that one more time. So the relationship is useful output energy is equal to efficiency as a decimal times the input energy. So we are just rearranging the efficiency formula in this case. So let's convert the percentage to a decimal. If we convert this percentage to a decimal, it's going to be 0.35, right? So 35% converted to a decimal will be 0.35. All right, now let's substitute all the known values into this formula. So the efficiency as a decimal will be 0.35. And what is the input energy? The input energy in this case is going to be 1 megajoule. And if we convert that to joules, it will be 1 million. So there should be 6 zeros. All right, remember efficiency doesn't have a unit. Okay, so if you punch this into your calculator, you will get 350,000 joules. So the useful work, now you have to state the final answer. The useful work is equal to 0.35 megajoule per 1 megajoule input energy. So what we did is we just converted the 350,000 joules to megajoules. So this is your final answer. So let's quickly do a sense check. With 35% efficiency, just over 1/3 of the input becomes useful output. So 0.35 megajoules out of 1 megajoule matches that idea. Let's quickly go back to this question. Why do we use vertical height in this formula? We use vertical height because gravity acts vertically. Only the vertical displacement works against gravity.